All right, guys, imagine you have two couples and the couple switch spouses. So the first wife is now married to the second husband, and the first husband is now married to the second wife. All right. That's basically a double replacement reaction, or sometimes called a double displacement reaction. And that's what we have over here. Notice over here what's happening. A and C are switching. So the original compounds were AB and CD, and the new compounds are CB and AD. And now let's look at that, like with this ridiculous example here. What do we see? We see that in this double replacement reaction, you start out with these two pairings here, and then they switch. And that's what happens in a double replacement reaction. Let's take a look at that with chemistry. We start out with sodium fluoride plus potassium chloride, and that yields sodium chloride and potassium fluoride. What's happening here? The sodium and the potassium are switching positions. All right, they're just switching with each other, so that there's basically a swap happening. Now, here's the thing to realize. Sodium and potassium both form positive ions. So you can't create NaK as one of the products. The things you can create are NaCl and K. Why can't you create NaK? Well, they both form positive ions, which means that if they're both positively charged, they would repel each other. That's not going to work. Positives attract negatives, but like charges repel. So two positive charges will repel and two negative charges will repel. Same thing with, the product wouldn't be fluorine chlorine or chlorine fluoride or whatever, because again, those aren't those would both form negative ions, and then they would repel each other. So how do you decide if something's going to be a positive ion or a negative ion? You have to know the atomic structure. So let's take a look. So let's start off with this thing. We see that this thing has 7 electrons in its outer shell. It wants to gain one more electron. And in order to gain, once it gains one more electron, it'll have a -1 charge. So this thing will form a negative ion. This thing, on the other hand, will form a positive ion. Why? It has 1 electron in its outer shell. It wants to get rid of that, causing this next shell to become the new outer shell. And the result being 1 less electron than before, so the same number of protons, and 1 less electron means it'll be a +1 charge. How can you figure that out from the periodic table? Remember, all of these things will form positive ions, and these things over here will form negative ions. Anything in group 1, these group 1 metals here in red, will want to lose 1 electron, so they're going to form a +1 charge. These are going to lose 2 electrons, form a +2 charge. And over here is going to want to gain 1 electron, form a -1 charge. So you can use the periodic table to help you figure out which one is which. But you must use either just the atomic structure, the periodic table, or some combination thereof to actually figure it out, so you don't create some sort of an idiot answer like NaK, because there's no such thing as NaK. You must actually know whether you're dealing with a positive ion or a negative ion, and 2 positive ions aren't going to attract each other. They're going to repel each other because like charges repel. Anyway, that's a double replacement reaction, and the analogy for that is basically 2 couples swapping spouses.